guys, welcome back to my channel. I'm David, and by the end of this video, you're going to have your very own full stack AWS project, something you can proudly add to your portfolio, and more importantly, something that gives you real hands-on experience building in the cloud. I'm an AWS community builder and one of the community leaders of AWS User Group Philippines. I've been in the tech industry for almost 2 years now, and I've always wanted to bring what we do in AWS communities here to my channel, especially beginner-friendly cloud projects like this one. I actually did a demo of this project during one of my recent tech talks, and it got such a great response that I thought, you know what, let's make this into a step-by-step tutorial. Now, quick disclaimer, this is a very beginner-friendly step-by-step project. I'll guide you through everything slowly, so if you've never touched AWS before, this video is for you. But if you're the kind of person who already has an in-depth knowledge or experience with AWS, you might not appreciate this video as much as the beginners. So think of this as a fun way to get your hands dirty, and by the end, you'll understand how real-world cloud apps work under the hood. So before we get into the setup, let me quickly show you what we'll be building. So it's a simple website where users can see a list of upcoming events, open the details, and RSVP if they're attending or not. On the front end, we have a clean landing page with event cards, each showing a title banner and a date. When I click one, it opens a modal that shows the full event details, an RSVP form, and live counts of who's going or not. When someone submits the form, their response is stored in a database, and those RSVP numbers update in real time. So behind the scenes, this is powered by multiple AWS services working together. So it's not just a front-end project, it's a complete cloud-connected app that looks simple but teaches you a lot of real-world architecture concepts. And I'll be discussing every service that I used later. So who is this for? This project is perfect for anyone who wants to build a solid portfolio project that shows you understand the fundamentals of full-stack AWS. Or if you've always wanted to explore AWS hands-on for the first time, or give yourself a reviewer or a refresher. You can even use this with your friends, organization, or interest clubs like a book club or a run club, or even for small event registrations. It's simple, but again, the architecture is something you can keep reusing and upgrading later. What makes this tutorial different than other AWS tutorials? Honestly, not much. There are tons of great AWS tutorials out there. But this one's a bit special to me because I follow one rule whenever I make content, which is I teach people the way I wish someone had taught me when I was starting out. So I'll explain each concept like how I would have wanted a mentor or a senior engineer to explain it to me. Clearly, step by step, and without skipping context. Do I need to know AWS to continue this project or to get started with this tutorial? Having AWS experience is definitely an advantage, but if you don't, no worries. I'll walk you through every step and explain things in a very beginner way. You'll be surprised how much you can do without writing hundreds of lines of code. So before we start, here's what you'll need. Number one is to install Node.js. This is to run your backend code locally before we deploy it to Lambda. So you'll also use it for packaging and testing API calls. Next is any IDE or text editor. Personally, I use VS Code. So this is for us to write the Lambda code, the front-end JavaScript, and other HTML files. Next is database client, like dbeaver or MySQL Workbench or anything you're familiar with. So this is to test and view our RDS or MySQL data easily. Next is Postman or Thunder Client or any API endpoint tester tool. So again, this is to test our API endpoints such as the GET, POST, etc. before connecting it to the front end. Now of course, optional but recommended, Git and GitHub. So this is to version control your code and share it as a portfolio project. So for the cost, don't worry, everything's within free tier. But if you keep your RDS database and CloudFront running 24/7, you might see a small cost, roughly around $0 to $5 total. I'll show you how to pause your setup later so you don't get billed after you're done, and I'll also show you how to set up a budget alarm so you get notified if you go over the limit of your budget for this project. So now that we're set up and ready to go, let's talk about what we're building, and I'll walk you through the architecture. what services we will use, and how everything connects together. Before we start building, let's go through a few key terms that will help you understand what's happening behind the scenes. Let's start with front end versus backend. The front end is everything the user sees: the website interface, buttons, and forms. It's built with HTML, CSS, and JavaScript and runs in your browser. The backend, on the other hand, is where all the logic and data live. It's the brain that decides what happens when you click something, like saving your RSVP or getting event details from the database. So again, in simple terms, backend, the logic and data; front end is what the users see and interact with. Now let's talk about CRUD. It stands for create, read, update, delete. So these are the four main things apps do with data. For example, in the RSVP event project that we'll be doing, create is when someone submits a new RSVP. Read is when we load the list of events. Update is when we change RSVP counts. Delete is if we remove an event. So create again is like inserting in SQL. Read is like selecting in SQL. Updating is update in SQL, so which is like you're changing or updating a record or a row, and delete is removing a record or a row. Now, let's talk about API. API stands for Application Programming Interface, but all you need to know for now is that it's the bridge between the front end and the back end. When you click a button or submit a form, your browser sends a request to the back end, and the backend sends a response back. So think of it like ordering food. You, the front end, places an order. You're like requesting a chicken meal. The kitchen, the backend, prepares that order. And the waiter, the API, delivers your food. Your food is the response. So there are also different kinds of requests. Get is to fetch data. Post is to send or create data. Put is to update existing data, and delete is to remove data. And in this project, we'll mostly use get and post. Now let's talk about the two types of databases we're gonna be using in this project: the SQL and NoSQL. So think of it like a spreadsheet versus sticky notes. Think of SQL like a spreadsheet in Excel or Google Sheets. Everything has rows, columns, and strict structure. In this project, we're gonna be defining the columns first, like the event name, the event venue, the event time, and every row must follow that structure. This makes SQL perfect for organized, relational data. Data that fits neatly into tables and has relationships. On the other hand, NoSQL is more like a collection of sticky notes. You can write different types of information in each node. It's flexible and doesn't require a fixed structure. So basically, in this project, the SQL part will store all the event details, things that are planned and organized. And NoSQL will store all the RSVP responses, things that change all the time. SQL is great when you need structured data and complex queries, like joining two tables or filtering events by date. But it can slow down when lots of people update the same record at once. Now, NoSQL is built for speed and scalability. It handles thousands of quick updates at the same time, like again, counting RSVPs in real time during an event. Now let's clear up one more important concept: traditional servers, virtual servers, and serverless. Before the cloud, companies used to buy physical servers, big heavy machines sitting in a data center or even in their office. These are what we call traditional servers. If you need to deploy a website, you have to buy the machine, install your operating system, patch it, set up networking, power coding everything manually. It's like owning your own restaurant. You buy the land, the kitchen equipment, hire staff, and you're responsible for everything, even when there are no customers. It gives you full control, but it's also expensive, slow to scale, and hard to maintain. Then came the cloud, and AWS was one of the first to offer it. Instead of buying physical machines, you can rent virtual servers from AWS using a service called EC2. It's like leasing a full equipped kitchen. You don't own it, but you can start cooking right away. You can choose the machine size or how powerful it is. You install your software, but AWS handles the electricity, networking, and hardware failures. You still have to manage the OS, updates, and scaling. But you can create or destroy servers in minutes instead of months. Honestly, in our project, we could have used EC2 for our backend. We will install Node.js there, connect it to the RDS, and expose it with a web server. But that means we'd have to manage uptime and scaling ourselves. And my goal again for this project is for you to get hands-on experience in AWS console. So now comes the modern era, the serverless computing era. Serverless doesn't mean no servers. It just means you don't have to manage them yourself. In AWS, this is what Lambda does. With Lambda, you just upload your code and AWS automatically runs it whenever it's needed. Like when someone again submits an RSVP or opens an event page. You don't have to worry about setting up or renting virtual servers or even scaling them or the idle time. AWS automatically handles that and even adds more capacity when traffic increases. And then you only pay when your code actually runs or when the Lambda triggers. In this project, the backend uses AWS Lambda, which automatically runs my Node.js code only when someone interacts with the app. So instead of paying for a full-time EC2 virtual server, I only pay for the milliseconds that my code is running. That's why serverless is so powerful for modern developers. It's affordable, scalable, and easy to maintain. So to summarize, traditional servers, you own the machine. Virtual servers like EC2, you rent the machine and it's in the cloud. But serverless, you just run your code. No machine setup needed. AWS takes care of all the heavy lifting, so you can focus on building features and not managing infrastructure. So let's now set up a budget alarm. Once you have logged into your AWS console, let us search here, bills. Next, let's look for budgets. So it's under budgets and planning. So as you can see, there's already a my zero spend budget here. So I did that way before just to check if I've already finished or already over the limit of my free tier. So let's click create budget right here. The first option is a budget that will notify you once your spending exceeds $0.01. So this is perfect if you want to stay in your free tier. So here are the other templates, but for now we'll be choosing the monthly cost budget. So we will create a monthly budget that will notify you if you exceed or are forecasted to exceed the budget amount. So you can just name your budget whatever you like, but right here in the enter your budget amount, I will be inputting 10, but you can input lowers. So this just means that I want to be notified if my monthly budget will about to exceed $10 or if it has reached $10. So here in the email recipients, you can just type all the email addresses that you want to be notified. So it says here you will be notified when your actual spend reaches 85% or your actual spend reaches 100% or if your forecasted spend is expected to reach 100%. So in my past budget alarms, I already received this kind of email. And this is what it looks like. Okay, so once you're all done and all set for your budget type, let's just create a budget right here. So by setting budgets, if you ever go beyond the free tier or something runs too long, AWS will send you an email before it gets expensive. So I do this for every project. It's the best 5 minutes you'll ever spend on AWS. Alright, so now that we have set a budget, we will start setting up the actual services, beginning with RDS, our relational database for storing event details. Alright, so now that we understand the architecture and we have set the budget, let's start building our backend. The first thing you have to do is to set this region to Singapore. So we're gonna be setting up all our AWS services in the Singapore region. And then let's begin with the database layer using Amazon RDS. So let's type here RDS. So RDS stands for Relational Database Service. It's basically a full managed database that saves you the hassle of maintaining a server, installing MySQL, or configuring backups. So for this project, we will use MySQL to store all our event details such as titles, dates, and venues. So let's click Database and create database. Alright, so we will be doing a standard create, and here are the engine options. So for this project, we will select MySQL. So after choosing MySQL, we will use the free tier template. So the free tier template is to develop again new application, text, existing application, or gain hands-on experience with Amazon RDS, which is perfect for our project. But eventually in the tech industry, you will have experience using dev desk or even production kind of templates. So when you create an RDS database, AWS asks where to physically host it. So an availability zone is basically one data center inside an AWS region. Again, our AWS region is AP Southeast 1, Singapore. Now, when we choose free tier, it will automatically choose this one. So single AZ means your database runs in only one data center or one availability zone. It has one primary instance that handles all reads and writes. And if that AZ has an outage, for example, that one availability zone is not functioning well, your database would temporarily be unavailable. So this is why for dev test or even production, multiple AZ choices is available, because it just means that when we choose multiple availability Zs or multiple availability zones, AWS will automatically create a second copy of your database in a different data center. So it means that if an availability zone fails, it will automatically switch to another availability zone. This gives you 99.99% uptime, which means your database will always run and it has better redundancy. But then again, it will cost you double. So since our event RSVP app is just a demo and not production, perfect combination is single availability zone with the free tier. It's cheaper, simple to manage, and totally fine for learning or small scale usage. So now let's just name our DB instance identifier. So for example, let's just type here event RSVP DB. There. And then you have to set a master username, for example admin, and enter a password you will remember. So for instance class, we will use dbt3 micro, because that's the free tier eligible option. For instance configuration, just think of it as the part where you're picking what size of virtual machine your RDS database will run on, similar to choosing how powerful your computer will be. Now, AWS offers many types of DB instances like T3, M5, R6G, etc. And each one defines how many CPU or virtual CPU power, how much RAM, memory, and how much it balances cost versus performance. The DB means database instance. So this is again an RDS machine. T3 means the instance family. T means it's a burstable instance, which means it can handle small spikes in usage but is meant for low to moderate workloads. Micro is the size. This is the smallest size available, which means you will be using 2 vCPUs and 1 GB of RAM. So it means DBT3 Micro is a small, low-cost instance type designed for light workloads and testing. Now, what does burstable mean? So again, T3 stands for burstable performance. It means that your database will run on a small baseline of CPU but can temporarily burst up to full CPU power when needed. So when more CPU power is needed, for example, 100 of users will submit RSVP at once, it will use the whole capacity or the maximum CPU power. So for our project, it will only have a few queries like fetching events, inserting RSVPs, and updating counts. That's why our DBT3 Micro is perfect. The more powerful the instance configuration, of course, the more expensive. Now, this is the part most beginners struggle with, so let's go slow here. Under connectivity, make sure you follow this exactly. We will not be connecting to an EC2 compute resource. And for VPC, choose your default VPC if it's already here on the options below. For me, it just says create new VPC, so I'm just gonna create a new VPC. Now, what is a VPC? So every AWS account comes with a private network called a VPC. It's like your own mini data center inside AWS. So a VPC defines which machines like RDS, EC2, Lambda can talk to each other, what their IP addresses are, and whether they can connect to the internet. You can think of it as if AWS is a big city, a VPC is your own gated subdivision and only your resources live there. So when you create a database, you're basically saying, I want my RDS to live inside this specific neighborhood or VPC. Inside your VPC, there are smaller sections called subnets. These represent different availability zones like data centers in different buildings. A DB subnet group is just a collection of those subnets that RDS is allowed to use. So, for example, if my VPC is a neighborhood, then the subnets are the streets. And a DP subnet group is a list of streets where my database is allowed to live. So since this is just a demo and we're using the free tier, we'll just use again the default VPC and let AWS automatically create a DB subnet group for us. It will pick 2 subnets from our default network behind the scenes. So no extra setup needed. So when you see VPC and DB subnet group, don't panic. You're just telling AWS where your database lives. So public access, just choose yes. And for VPC security group, we will choose existing. So default. So these are just some extra options you don't have to worry for now. So when you're creating a database instance, do not forget to check the additional configuration and set up an initial database name. So I'm just gonna create here events DB. Now let's create our database. And you will see that our RDS instance is being created. Now that the status of the DB instance is available, let's check a few things before continuing. First, the publicly accessible must say yes. And second, we will check the VPC security group. So VPC security group, this is basically like a firewall for your AWS resources. So think of your VPC again as your private neighborhood inside AWS. And every house, like your RDS database house, EC2 instance house, or Lambda function house, has its own security guard standing at the gate. That security guard is called the security group, and its job is to decide who's allowed to come in and what kind of traffic is allowed. So in this case, we're assigning a security group to our RDS database. It's like saying only people who meet these rules can knock on the door of my database. For example, if I allow traffic on port 3306, the MySQL port, and only from my computer's IP address, that means only my laptop can connect to the database and nothing else on the internet can touch it. So again, I said that when you create an RDS database, AWS automatically puts it inside your VPC, and it attaches the security group as its protection layer. So let's visit our VPC security group. And then we will edit our inbound rules. Okay? There. So here you will see the source. Source defines who is allowed to access your RDS database. So custom means only resources inside AWS like Lambda or EC2 with the same security group can connect. And my IP means only your current computer's IP address can access. So since we're still setting up and connecting from our local machine like dbeaver, we will set it to my IP. So let's just delete this one and just add it again. So let's put all traffic and set this to my IP. It just means that only my computer can connect to my RDS on port 3306. It's safe and we will still be able to test everything locally. When we go back, you will see here security group rules. So this page shows who can connect to our RDS and who our RDS can connect out to. So inbound rules means who's allowed to come in, and outbound rules is who's allowed to go out. So if you look at the first line, it says inbound, and under the rule, we have our IP address. So remember, your inbound rule keeps your database private and secure, and you should never open it to 0.0.0.0/0 unless you're absolutely sure what you're doing. So now that our DB instance is all set up, we will now be using our database client tool to test our connection. So in my case, or in personally, I use dbeaver. Now let's create a new database connection. We will choose MySQL, next, and then click this URL. Now let's copy our endpoint right here, and we will replace this. Then put event db, or whatever the initial database name that you set. Now let's use the credentials that you also set earlier when we were configuring our database instance. Now let's click here, connection details, and instead of localhost, just put event RSVP SQL. Go back here, let's test the connection. So it says that it's connected. Once that you confirm that it's connected, you may finish. And now you will see right here our MySQL database. Again, if you were unable to successfully make a connection, make sure that you are in the correct region. Make sure that publicly access is yes, and your security group allows your IP address. And make sure to also include the database name at the end of the JDBC URL. So again, when we look this, there. Now that we are already connected to our RDS instance, we will now create our table. So we will open a SQL script right here, and let's create a table named events. Of course, our event will have event ID, which will be our primary key. Next, we're gonna have title. We're gonna have description of the event. We're gonna have start at for the time. We're gonna have a venue. Of course, we're gonna have a banner URL so it will look better on our website. And I would like a created at for timestamp purposes, so I know when the event was created or inserted in the table. I did was just to set it properly with the proper data type. So we have here varchar, text, date time, and timestamp. So let's execute this SQL. So now we have our table named events. This structure stores everything we need: the event name and description, the schedule and the venue, and a banner URL which we will fill up later, and a timestamp again for when the event was created. So if we try to select from the table, it will not show anything because it's empty. So now we will insert our sample event. So let's just insert a few sample events so our front end will have something to display later. Okay, insert into events. Of course, we're gonna copy our column names. So I will just copy paste it right here. And now we will say we will insert two rows. So we will insert two events. So this is gonna be our event ID. This is the title, the description. It starts at this date and time. The venue, we're gonna leave the banner URL blank for now. So now let's insert this and let's check. So we can already see that we have two events ready. Okay? Quick reminder, if you're not using your RDS yet, let's say that you set up your RDS instance and you went somewhere or you went to sleep and you haven't really tested the connection or did all of this stuff, If you're not using your RDS yet, or you think it might take you a few days before continuing this tutorial, it's better to stop your RDS instance temporarily. If you're not gonna use your instance for now, you have to stop it temporarily. Don't delete it, just stop it from the console. Here's why. When RDS is running, even if you're not connected, you're still billed for the compute time. So stopping the database pauses that, and your data stays safely stored in the underlying volume. So for a small project like this, if you keep it running again 24/7, it will cost you like $0 to $5. But if you stop it between sessions, for example, you're gonna stop it and then continue the tutorial for another day, it will stay close to zero under the free tier. If you're wondering, should we create another table for attendees? In this project, we will not store the RSVP responses in the MySQL database. Instead, we will handle all RSVP submissions and counts inside DynamoDB because, again, it's a NoSQL database. It's faster and more flexible for live updates. So this RDS layer right here focuses only on static data, the event details. Now, we will take our dynamic data, like who said yes or no, to DynamoDB. So before we move on to the NoSQL part, let's have a recap of what we've done. So we created an RDS MySQL database. We configured the correct network and security rules. We connected through our database client tool, in my case, dbeaver. We created our events table, and we added a sample data. So if your test query worked and you can see your data, that means that database layer part 1 is complete, and we will move on to DynamoDB. See you in the next part. Now that our event database in RDS is ready, it's time to build the second part of our data layer, the one that tracks RSVPs in real time. For that, we'll be using Amazon DynamoDB. If RDS was our structured storage for event details, DynamoDB will be our fast counter, keeping track of who's RSVP'd and how many said yes or no. So it's a fully managed NoSQL database, which means we don't need to worry about tables or schemas or indexes or scaling. It automatically handles those for us. So now let's go to DynamoDB. Let's create our table, and we will use a table name. So just say event RSVP responses. There. For the partition key, just put PK, and for the sort key, just put SK. And let's create our table. Once the table is active, let me show you how it will look conceptually. So each item or row in DynamoDB will have event ID, which event the RSVP belongs to, the email, the attendee's email, full name, their name, response, yes or no. And later, we'll also use the same table to quickly count how many said yes or no using our Lambda function. You will see that in DynamoDB, we didn't define columns like in MySQL. Instead, we defined our keys, which are used to uniquely identify and organize your data. So for the PK, think of it as the folder name. All items that belong to the same folder share the same PK. So in our app, the folder is the event ID. Now for SK, this is like the file name inside the folder. So we're gonna use prefixes in the sort key to create subfolders or categories where we can query easily. So for this project, we're gonna have two SKs or two prefixes. One is the respondent for the email, so it's like one file per attendee. And SK responds yes or SK responds no. So the table is a single place where all events, all attendees, and the running counts live, separated neatly by the PK folder and organized by the SK file naming. So again, SK can be respondent email, response yes, or response no. So why do we use this? So DynamoDB performs best when you model your access patterns. So this is what we call single table design in DynamoDB. So when someone submits an RSVP, we atomically write two items with a transaction, attendee record and counter record. So both items share the same PK but have different SK. For example, we want to get all the attendees for an event. We will query using the PK and this SK, which is respondent and the email. But when we want to see how many said yes or no, or if we want to count, we will use SK response yes or SK response no. So I won't be adding any items in our DynamoDB for now since it will make more sense later. So again, quick cost reminder before we move on. DynamoDB is almost always free for small projects like this. It has a generous free tier. So unless you're building a viral RSVP app with thousands of users, you won't see any DynamoDB charges at all. So you can just leave it running safely. So to recap this part, we created a DynamoDB table called Event RSVP Responses. We defined its primary keys, and yeah, that's it. Your NoSQL layer is ready. And as you can see, we are also done with our database layer. Next, we will move on to our backend, where we will connect both of these databases, RDS and DynamoDB, to our Lambda and build our actual API endpoints. That's where all the fun begins. So, see you there. If you have reached this far, give yourself a round of applause. Congratulations, because now that our databases are ready, it's time to build the brain of our application, the backend. Now this is where the logic lives, fetching events from RDS, recording RSVPs into DynamoDB, and connecting everything to AWS services. This part, we will build our backend using AWS Lambda for the code and API Gateway for the routes, so the front end can call it later to simple URLs. So what is AWS Lambda? It's a service that lets you run code without managing any servers. Normally, you would need to launch a server, install Node.js, deploy your app, and keep that server running 24/7. With Lambda, you don't need any of that. You just upload your code, and AWS runs it only when needed. Now, how does your front end, the website, actually talk to Lambda? That's where API Gateway comes in. API Gateway is like the reception desk of your backend. It listens for requests from users, like when someone opens an event or submits a form, and forwards them to the right Lambda function. Imagine your website says, "Hey, I want the list of events." The API Gateway hears that, it tells Lambda, and Lambda fetches from the database and sends it back. So again, API Gateway is like the middleman between the front end and the back end code, and Lambda is the worker that actually does the job. Now let's create our Lambda function. Let's go to Lambda. Let's click create a function. Let's just say author from scratch for now. Function name, we can use it as event RSVP handler. The Node.js can stay. And then architecture, let's just put it like this one. Then under change default execution role, choose the create a new role with basic Lambda permissions. This will add more permissions later. Finally, let's click create function. Alright, once it's created, scroll down to the configuration tab, general configuration, and let's increase the timeout to at least 15 or 30 seconds. Because 3 seconds is too short when connecting to the RDS. Save like this right here. Then under configuration and environment variables, click edit and add the following: DB host, DB user, DB pass, DB name, and region. Put your endpoint, your user, your password, events DB, and the region AP Southeast 1. Next is under the permissions tab, click your role name. So what are we doing here? Before we can connect our Lambda to other AWS services like RDS or DynamoDB, we need to talk about something called a role. A role in AWS is basically a set of permissions that tells AWS what a service is allowed to do. It's like an ID badge that comes with a list of what that person or service, like Lambda, is allowed to access. Imagine you work in a company, and not everyone has access to every room. Your badge might open the office door but not the finance room. So same in AWS, your Lambda function can automatically access database DynamoDB tables or VPCs unless you give it permission through a role. So this is the role, right? So this is a role. Because by default, Lambda is isolated. It can only run code, nothing else. But in our project, our Lambda needs to connect to the RDS database inside the VPC. It needs to read and write data in DynamoDB. So we give it a role, like this is the role, that grants this specific permission, saying, hey AWS, this Lambda is allowed to connect to the VPC and talk to the DynamoDB. So why is this important? AWS uses roles to make sure each service can only do what it needs, nothing more. That means even if something goes wrong with your Lambda, it cannot touch services or data it doesn't have permission for. It's like giving your friend a house key only for your gate and not for your bedroom or your safe. Now, let's add permissions. Let's attach policies. First, let's search AWS Lambda VPC. So what this does, it lets Lambda connect to resources inside your VPC, like your RDS database. Why is it needed? Without this, your Lambda cannot reach RDS. Next, let's add Amazon DynamoDB full access. And maybe let's add the version 2. So this allows Lambda to read or write RSVP data in your DynamoDB table. Let's set the permissions. Add the permissions. Okay, now our Lambda have the following permissions. So it gives permission to talk to other AWS services securely. Because without it, even if my code is perfect, it won't be able to connect to RDS or DynamoDB. Alright? Now, going back, let's go to VPC. And let's click edit. Attach it to the same VPC where your RDS lives and select the same subnets and the security group. Why? Because Lambda and RDS must be in the same VPC, in the same neighborhood to communicate. Now, save this. So you can see it worked because we already gave it permission to do so. Okay, now that it's all set, let's go back to the code. And let's open this index.mjs file. Delete everything there. And let's start coding our main logic that will connect our front end to databases. First, we will import the following. So this section of the code is just saying I need my tools ready to communicate with the database. So MySQL, of course, is the tool to talk to the RDS, and DynamoDB client and the command like update the item, put the item, and the query commands. It's just these are the tools to talk to DynamoDB. Now let's go to section 2. So I'll explain line by line. What is handler? So handler, think of it as the doorbell button. When someone visits your Lambda URL, which will be shown later, AWS presses the doorbell. Handler is the function that answers the door. It's mandatory. Every Lambda needs a handler function. Export means this function just can be called from outside. And async means I might need to wait for things like databases, so please be patient. Line 16 is just writes information to the log, so we will see what's happening. What is event? So the event is like a package delivered to your door. It contains all the information about the request. So what is the method? The method is like get, post, put. What is the path? The path is like the URL. Like slash like this, slash like that. It's like where do they want to go? The path parameters is like the wildcards in the URL. And then we have some query string parameters and body and headers. Just some URL stuff. Now, what is JSON stringify? When we do console.log event, it will just show object. It will just show this, which is useless. Now, JSON stringify, it shows the actual content in a readable way, in a JSON type kind of file. Now, the next section just asks, before you enter, are you even allowed to be here? So browser sends this options request first to check security rules. So here you're like saying that yes, anyone can talk to me from any website. So these are the allowed methods, these are the allowed headers, etc., etc. In this section, we're just creating a connection just like what we did in dbeaver. Let's go to scenario number 1. It says here, if the method is get and it starts with event, you execute the following. Here's an example of what it looks like. So the user asks get event meetup, and it will look up event ID meetup in the RDS, and then it will reply, here's the event title, description, etc. That's why it in line 50 it says, this is the query that you will execute in the RDS. Select asterisk from events where event ID, it will get meetup. So for other scenarios, it follows the same pattern or structure. It will check the method, it will check the path, and it will look for the event ID. So for this get stats event ID, this time we are communicating with DynamoDB. It says here that please look for the event where the event ID, and the response is yes or no. So here in the event ID, we're communicating with RDS. But here in the stats, since again our RSVP counts is stored in DynamoDB, it will communicate with DynamoDB. It says here that responses that it should look for is yes and no. And it will look for the combination of the event ID plus email, right? So we're gonna map it out. Then it will batch get. It means it will get all the unique combinations of event responses. That's why it's batch get item command as we imported here. In this section, it will just count how many yeses, how many no, and then return that. Next scenario is we have a post. It means someone wants to RSVP. So if the method is post and the path is /RSVP, it will look for the event ID, full name, email response, and it will set it as the body. In this section, first it checks if the combination of the event and email is already existing, because that means that certain email or that person already RSVP'd on the same event. It will add 1 to the counter for yes or no. Again, input, it gets the event ID and respondent email. But in update, since we will update the live count, it will get the event ID, and response, which is yes or no. The following are just proper error messages. Next is scenario number 4. It's another get. So we see the same structure. It checks the get, it checks the path, and then it will get the event ID. What this does is it will look up all the people who RSVP'd for that certain or specific event ID. Next is another get. It's just saying, show me all the events. So it's gonna fetch all the events in the RDS. So what's it gonna do is gonna get all the events from the RDS sorted by date, and then it will respond with all the upcoming events. For the fallback section, it just says that if anything breaks, don't crash, handle it gracefully. So it just shows what kind of error, if ever there's one. So what is CORS? CORS is like the bouncer at each club that checks the IDs. Without CORS, any website could secretly talk to your API and do bad things. So for every response or request, there is the CORS checks the ID, or like if it's allowed in the club, like there's a rule book. For this line, who is allowed to respond and request? What can they do? What can they bring? And can they bring cookies? So again, this Lambda code, it listens to what the user wants. It decides which database to use or to call or to communicate with, MySQL or DynamoDB. It performs the right action. It gets the stats, it posts or it inserts a record, it packages the response nicely, and handles errors gracefully. So that's basically what the code is saying here. If you feel kinda lost in this part, don't worry, it will make more sense later as we test our API. But first, let's deploy our code. There. Now this Lambda has a code. What will make the Lambda do its job? The trigger. So we will add a trigger right here. And we will choose API Gateway. So let's go to API Gateway. Now let's create an API and let's choose HTTP API. So API name, let's just say our event RSVP API. Then for integrations, choose Lambda function. Choose Lambda. Then let's get the Lambda function that we built earlier. So here we're just specifying the backend services that our API will communicate with. Next, let's add these routes. We're gonna have get events, get event ID. Then we're gonna have post. So as you can see, this is all from our Lambda code. That's event ID and get attendees, path parameter, event ID. So our routes are like saying we're gonna get all the events, we're gonna get a specific event, we're gonna RSVP to an event, we're gonna get the live count of the event or an event, and we're gonna get all the attendees of an event. Okay, so let's click next. Let's just click next again. So let's just review. Get event ID, and let's click create. So let's go to course. So let's just put a wildcard for now. For this one, let's also just put a wildcard. And for allow headers, just put the following. So let's go to our API. Click this one. You will see all the details about our API. And you will see a default endpoint. So we finally have an endpoint. Copy the endpoint. And now the fun part, let's test our backend. So personally, I use Postman. So now we're in Postman. Let's create a collection. Let's name it event RSVP. And let's try adding a request. So we're gonna do get, and we're gonna paste the endpoint right here and click and type events to get all the events. So let's send it. So here you will see an error. Let's check why. If you see an error not that specific, you can go to CloudWatch. And check our logs. Go to log groups, and you'll see right here the event RSVP handler. So let me just delete this so it's not confusing. There. As you can see here, so this is the time that I triggered my Lambda. And it says here that cannot find package MySQL 2. So the error is just basically saying our Lambda function is missing the MySQL 2 package. Why? Because when you put code directly in Lambda, it doesn't automatically include external libraries. So this is why I told you guys to install Node.js, because I'm gonna show you how to fix this. Now, copy the code and go to your IDE. Open or create a folder, and let's create a new file. Let's call it index.js. Now let's paste the code right here and let's save it. So in this part, you can use Git or GitHub now for your version control. Now let's create another file. Let's call it package.json. Then let's run the terminal. Let's run npmi. So what we just did is that we created a package.json that's like a recipe card. Like what the project is called, or what packages, or what are the dependencies of this project. And then we run npmi. This is like going to the grocery store to get all the ingredients. So this npmi command, it reads your package.json, it downloads all the dependencies, and stores them into the node_modules folder. So the npmi, it found out that the project needs MySQL 2 installed with this version, AWS SDK client DynamoDB with this version. So it downloaded that version. So it downloaded those dependencies to make the project or the backend work. So again, index.js is the Lambda code, package.js is the list of dependencies, and then package.json is the exact versions of everything. That's why it's more specific. And then the node modules is all the downloaded packages. Now what we're gonna do is we have to zip it up. So make sure you're in the correct directory. Let's type here ls. Okay, we're in the correct directory, and we're gonna create a zip file. So rsvp-backend.zip. Okay, I forgot the dot. The dot means to include all the files in that zip folder. Okay, there you go. And if you check, we have a zip file. Okay, now let's go back to the console. Now here, click upload from that zip file, then upload, then save. We have something to confirm before we move on. Make sure that the file name, dot, and the handler name is right here in the runtime settings. I said earlier that handler is mandatory. So, but the naming convention can be different per code. So, we just have to make sure that it will look for index.handler. Quick bug fix in case you encounter. Don't forget that in our code, you have to change, or you have to hard code the DynamoDB name. So, in my case, it's responses, not count. So let's just make sure. See? So make sure you properly set your DynamoDB name throughout the code. Okay, so all my table names, let's just fix it quickly. Okay. So if I want to change something, if I want to fix a bug, I don't have to put it on VS Code. I don't have to code it on VS Code and then, npmi and then zip it all again and upload it here, unless you have another dependency to install. So here, this is just a quick bug fix. So I directly fixed it on the AWS console rather than, or instead of, in VS Code. So let's just deploy it. So it still shows error. Let's check again why. So we can see that we click send, so that means it triggered the Lambda function. This time the error is timeout. Okay, hold on. So earlier we saw that our Lambda is attached to the same security groups, the same VPC as the one in our RDS instance. So here you can see that our Lambda has the same security group with our RDS instance. See, they're the same. But if I run it on Postman to check, it says it's not found. Since even though both your Lambda and RDS use the same security group, that doesn't automatically mean they can talk to each other. So they still don't automatically trust themselves, even if the same group is attached to both resources. So by default, security group rules only allow traffic from specified sources. Me personally, what I do if I encounter errors with testing my APIs, I first check at the CloudWatch. If it's not in the CloudWatch or if it still doesn't work, I go now to the security group. So I just want to share that make sure if you go to the security group. So let's go to the security group and let's edit the inbound rules. So originally we have this, right? Like our IP address can access. Let's add another group here where it's also MySQL. And let's paste here the name of the security group. So copy this one, paste it here, and save the rules. Okay? So even if two rooms use the same kind of lock, two rooms like the Lambda and the RDS, you still have to explicitly instruct it. These inbound rules, it tells AWS that Lambda and RDS can safely talk to each other inside the same private network. So you can see in this diagram that our Lambda again is triggered by our API gateways. So we have here the roots, we have here /events, /RSVP, /event, /stats, and /attendees with a common path parameter, which is event_ID. So let's copy this and paste it on our Postman. So get events, right? Just like in our Lambda code. And when we send this, it will show the events in JSON format. Why? Because even though it's from RDS, see, it's the same. So even though it's from RDS, the way it was structured was in JSON because in our Lambda code, we packaged it again, right? We packaged the response nicely. So if we look at the Lambda code right here, see, we JSON stringify it. And let's check CloudWatch. Again, CloudWatch, there's a log group there where you can see what happens each time we trigger the Lambda function. Received event, and then the whole JSON stringified body. So here it's this one. Let's see. So it ran this line. See? Received event, and everything's here. You can see here the method, the path. So that's what we called in our Lambda code, the method and the path. See, request context HTTP method. So this is the event, request context HTTP, and then method. So that's how it works. Now we can finally test the rest of our APIs using Postman. So here we can name it list events. Now let's try another get. Let's try to get a specific event. So let's add another get here. Then this time we will call an event ID. As you can see here in dbeaver, it's this one. So let's copy this. Let's paste it. And then Let's send it. Sorry. So this is a common mistake. Make sure to always double check your root. So it's actually event because we're gonna get one event only. See? So here we listed all the events. Here we just got one event. So here, let's say get event. So how did this work? So again, this is the path and this is the path parameter. And if we look at it on Lambda, let's check the code right here. It says if the method is get and the path is event, look for the path parameter event ID. And then select from events where event ID is the path parameter. So that's what it's trying to do. So just like in the Lambda code, if the method is get and the path is event, get the path parameter, and then it will select it in the beaver. So in the beaver, if we try it that way, for example like this, and if we run it, it's gonna get the details of the AWS Builder Cards tournament. Alright, see? So it displayed the specific with the specific event ID. Now let's try it again with the rest of the APIs. This time, let's do a post. Post means you're creating a record. So let's get the endpoint right here. Let's change the path. We're gonna RSVP and we're going to create the payload. We're gonna create the payload in JSON. We're gonna create the request. Here. So our event ID is, for example, AWS Meetup Manila 2025. Now, where is the event ID from? Again, it's from the dbeaver. So if we select the events, see, AWS Meetup Manila 2025. Full name, let's say Darla David, and email darla@example.com, and response yes. So this JSON is saying that Darla David with this email responded yes in this event ID. So let me explain to you the difference between the payload or request versus the body. So the request or the payload is the entire package being sent. What is the method, what is the URL, what is the path, the headers, and the body. Now the body is the part of the payload. So it's a part of the payload, which is just the data inside, which is you can see here. So now we have another error. So why is this happening? Unlike our first two APIs that we tested, this time we're connecting to DynamoDB. Now, Lambda is inside VPC. And DynamoDB is a public service. So when we say DynamoDB is a public service, it's not required to put it in a VPC because it's accessible from anywhere on the internet. So in AWS, there are public services like AWS S3, SNS, SQS. So they use public AWS endpoints. So the problem here is that when the Lambda is in the VPC or in the neighborhood, it can visit RDS because they're in the same neighborhood. But it cannot visit DynamoDB because in order to visit DynamoDB, it needs to leave the neighborhood or it needs to be, outside the VPC. But when Lambda is outside VPC, it cannot visit RDS because VPC again is a neighborhood, it's a gated community. But it can visit DynamoDB. Why is DynamoDB a public service? And why is RDS considered like a private or like needed to be inside the VPC? Because in DynamoDB, AWS manages everything. It's like a serverless database. As you can see, it was harder to configure RDS, diba? We went through a lot of configuration compared to DynamoDB where we just put a primary key and sort key. Because in RDS, we manage the database from the versions, the schemas to the users, and we also control the network access. So DynamoDB is a managed service, meaning AWS controls security at infrastructure level. You only control the DynamoDB via the IAM role that we did, right? We just gave it permissions. But with RDS, we were able to manage everything. How will we reach DynamoDB if our Lambda is inside our VPC? Now, there are two ways. First is not gateway. It's another service, but it's more expensive than the other path that we will do, which is to put a VPC endpoint for DynamoDB. So once we're in the VPC in the console, we go to the endpoints. And then we're going to create an endpoint for DynamoDB. So we choose AWS Services, and we will choose, make sure it's on, oh see, I almost made a mistake here. So make sure you switch to the appropriate region. And let's try it again. So DynamoDB, again, make sure it's in the region where your AWS services are configured. For the VPC, let's use the same one our Lambda uses. And for the root table, just click this. And then for the policy, just leave it as full access. And let's create our endpoint. Okay. So for example, event ID again, full name, email, and yes. So if we click send, if we trigger the Lambda function, it's gonna say the RSVP has been recorded. So what happened? Again, this is the request, right? This is the whole request, and this is the response. Let's check our DynamoDB. So we have 2 items returned, but with one payload or one request. So as you can see in this item right here, it has a different you may say data than here in the second item. But still, again, since DynamoDB is NoSQL, it's flexible. It accepts that it accepts like a flexible schema or a structure. Okay. Let's add another attendee. This time he will say no. So it's gonna be recorded. Now let's try yes for John Doe. Now we're expecting that this is not gonna work since John Doe already voted no for the same event. So it captured the error. Now let's try another API, which is getting the statistics. Get responses count. Let's see. Just change the path. See. So as you can see, 0 because let's try a different. Let's change the event ID. You will see that there's 1 yes and 1 no. And if we want to see who are the attendees for the event, let's have another API call. This time, we're gonna get the attendees. Okay, so here you can see that here are the attendees or the people who are SVP'd in AWS Meetup Manila 2025. We have Darla for yes and John Doe for no. So the difference again between the stats is we're just getting the count, but here we're gonna get the whole details. So as you can see, we were able to test all our APIs. Again, we listed all our events. We got a detail of an event. We got the details of one event. We RSVP'd. So we sent out an RSVP, and then we checked the responses count, how many said yes, how many said no, and who are the attendees who RSVP'd so far in this event. Good. So using Postman, we were able to test all our APIs. Again, we used our URL, our API gateway URL or endpoint with the path, and then the path parameter. Then we also learned the payload and the difference between request and response. So, now you understand the flow of the backend. The front end will send an HTTP request. Again, for example, the path /RSVP/events. And that request goes through API Gateway. And the API Gateway will trigger the Lambda function. And inside that Lambda, we were able to communicate or to connect to both RDS and DynamoDB. How? Again, RDS because Lambda was inside the VPC, and DynamoDB because we created a VPC endpoint for that. So even though DynamoDB is a public service, it was able to connect to the Lambda, which is inside the VPC. Then, again, Lambda returns a JSON response, right? The stringify thing. So either event data or a confirmation or even the error. And API Gateway was like the messenger. And then Lambda is the one doing the actual work behind the scenes. So we created our Lambda backend. We learned how to create our Lambda backend. We learned how to connect our RDS and DynamoDB. We attached the correct permissions. We built our API gateway routes, and we tested everything with Postman. That means our entire backend layer is done. It's fully serverless and fully cloud powered. So now that we're done with the backend, since we have the RDS layer, the DynamoDB layer, which made up the database layer, and we have API gateway and the Lambda function, which made up the backend layer, we'll be moving on now to the front end, where we will host our website on S3 and CloudFront. We will connect it to the backend, and finally make our app go live. I'll see you in the next part. Now that we are done with the backend, we will now focus on the front end. So for front end, we'll be using HTML, CSS, and JavaScript. With those three, we will be able to create a small website that lists the event and let users RSVP in real time. First, let's start with the HTML file. So let's just create our this file right here. Okay, so this section is just saying that this is an HTML5 document. The page content is in English. Here it just says that to use modern text encoding. This line means just make it look good on phones. And of course, this is the text shown in the browser tab. So we will do it as AWS User Group Philippine events or any event that you would like. Here we're just saying to use the CSS file for styling. So this is going to be the name of our CSS file. And this is the icon that the browser tab will use, which is going to be a party emoji. But anything you'd like, honestly, it will work just fine. Now we have here the body. So body is everything that is visible on the page. It will go right here. So we have the container, which is like the main box that holds everything. We have the header, which is the top section with the title and description. And this part, so it will say AWS User Group Philippine events, and just a quick paragraph that says discover and RSVP to our 2025 events. And this section is just going to be an empty container where our events will appear. And the div class loading is just says that it will show loading events while waiting for the data. So the events grid, this is empty because the JavaScript will fill it later. Now for the event modal, it will create a pop-up window, so it is going to be hidden by default. And then the ID or the name of the modal or the pop-up container is event modal. And then it will have a button, a close button, like an X button to close the pop-up. And it says here on click or when clicked, it will run the close modal function. So if we click the X button, it will close the modal. So this section right here, it will load the 3 JavaScript files that we will make, which is like the brains of the website. So let's check what this looks like. So you can use any method to check your local host or to run your local server. But for me, I use Python 3. So let's just boot up our local. Okay. So it says here serving on our local host. So we're going to check it. It's gonna look something like this. So it doesn't work, okay? So since it doesn't look like anything good, let's now focus on the design. So let's create another file called style.css. So this file will handle the look and the feel, you know, the colors, the layout, and animation. For here, we're just setting up the foundation, like the base or the layout. And of course, this section is all about the header. And this one is the event cars grid. So in the event cards grid section, we're just stating that we want it to be a responsive grid that will auto adjust the columns, and there will be a hover effects. So later you will see. It'll pop up. We just wanted like a full screen overlay. You know, it's hidden by default, and there will be a slide in animation when opening. For the statistics bar, we just want it like a 50-50 split with gray cards. So I just want it like a gray card. For the attendees table, I just said I just made it like I just wanted it like to have a clean table design with borders, and I want it to be scrollable when there's too many attendees. And for the RSVP form, or of course, there will be styled inputs and drop down, and an orange submit button with a hover effect. And for the others, just like, you know, a close button and a loading and error message. So you can customize it however you like. So let's just go back to the HTML file real quick. So since it's not gonna be, you know, a part of a folder or a directory, I'm just gonna remove this and save. So now that we refreshed the site, this is what it looks like now with the CSS implemented. Now it just says loading events since we haven't connected backend. In order to do that, we're going to create our JavaScript files. First, we'll be starting with a file called utils.js. So this file, this is gonna be the bridge between the front end and the back end. So this line points our front end to our API Gateway URL. So that's how our site will communicate with Lambda. So let's just update it. Make sure the API-based URL is from the API Gateway endpoint that you will see in your console. Let's just go to the API Gateway. Go here, default endpoint. Make sure you copy it, and let's paste it right here. There. So in order to communicate to the backend, we use the API-based URL and an endpoint. So the endpoint again is like the /events, the /RSVP. It's like the path. So we have this software engineering principle called DRY, or don't repeat yourself. So we have 5 APIs, but I'm not gonna do fetch API-based URL endpoint 5 times. Instead, we're gonna wrap it in a function. So this API call, it wraps the fetch API. So instead of repeating fetch code, we can just call this function anywhere. The rest of these are just helpers like format date, format time. So the event dates look nice on screen, and of course, close modal, which hides the pop-up. Now, the events.js, this is where the magic happens. So all the functions that will talk to the backend will be here. So we created the event-related function. So here, like I said, we did not repeat ourselves. Instead, we just called the function from utils.js. Now, this is the same with this one in the Postman. That's the same. It's basically the same. So this gets all the events. This gets a single event. This will get the yes or no counts. And this will get the list of the attendees. So the submit RSVP function, it will collect your payload. It will take your name, your email, and response. It will send it to the Lambda endpoint. See? Post, API call RSVP with the post method, just like the one we did in Postman, where the payload is in JSON form. Again, it will send it to the Lambda endpoint, and it will show a success or error message. And show message, it will just show the success or error messages, and then it will auto refresh the stats after a successful RSVP. Display event function, it just shows the event cards grid. The load event stats, it just updates the yes or no counters. And then the open event modal, of course, opens the pop-up with events details. So this events.js, it handles the complete event RSVP workflow. Now let's make another file called app.js. So this is the main application initialization. This time, it just waits for the HTML to fully load before running JavaScript. It's to prevent errors from trying to access elements that do not exist yet. This function is the main entry point for the entire application. It will call the load events to start loading the data, and of course, there's error handling. And for load events, it will just fetch events from your Lambda API, and it will pass this data to the display events to render the grid. So now we have our front-end files. Again, index.html is the structure. It's the main page of the website and contains the layout, so think of it as the skeleton of the whole app. So it will link you to the CSS file and to the JavaScript file. For the style CSS, this is the design. It handles how everything looks, from the fonts, colors, and spacing, to how responsive it's gonna be. This will make the event cards and pop-up modals visually appealing. The util.js, it will have the helper functions. It stores reusable utilities like the API call to talk to the backend, the format date and format time to display clean timestamps, and functions for opening or closing the modals. It's like your toolkit for small repeated tasks. Events.js is our main app logic. It handles all the data and API interactions. You know what to do when we fetch the events, or what to do when we submit an RSVP. This is the one that updates accounts and attendee lists dynamically. This is the entry point of the front end. When the page loads, it calls the functions that fetch events and display them on the screen. Again, let's just remove the directory because it doesn't belong to any folder. Let's just add another event. So we have 3, and this is what it looks like now. We have our fully functional RSVP form. So when we click, it kind of moves upward, and the banner is like a default image that we set in the code. And when we click this, it shows the banner again, more details about the event, and an option to RSVP to the event. If you remember, if we go to our DynamoDB, we already have our respondents from when we tested our API in Postman. They're not here, but they're here in the AWS Manila Meetup 2025. See? You will see that this is from the DynamoDB. Now let's try submitting an RSVP. Have here gmail.com response, and if we submit an RSVP, you can check your network right here. Let me just show you something. If we submit RSVP, it says RSVP submitted successfully, right? And it automatically refreshes and puts the going right here. Now you can see here the API call. It's the Lambda, it's the API URL, and the path, and the method. If you look at the payload, it's the details we passed earlier in this form. And the response is RSVP recorded. That's why it said earlier that it was submitted successfully. So again, it's similar to how we tested our API. This is the method, this is the URL, and the payload, and the response. It's the same right here. Request, method, request body or the payload, and the response of the API. So if we check the other paths, you will see here it got the specific event which showed or displayed the description, see, learn all about AWS Builder cards, and so on. Here it says 1 yes, 1 no, and the details of the attendee. Now let's try no. Submit it. You will see here successfully. It will load the event again, and Jessica will be right here. And the live count is also updated. Now let's try Jessica again. Say yes. Now it says you have already RSVP'd for this event with this email. So it handled the error properly. And if we look at the API call, it's the same. And the response is, you have already RSVP'd for the event with this email. With the code, duplicate RSVP. Now, if you find yourself stuck in this part, like there's a failed to fetch, like there's an error that states failed to fetch. And for example, it works on the Postman, but here it doesn't. I want you to double check this section and API Gateway. Alright, so at this point, we're done with our front end. We have connected it to our back end, and everything's working perfectly together. Also, we successfully tested it locally, meaning it's just running from my computer or your device. So when we're developing, that's usually how we test first, in our local, where all the files are on your own machine. But now, if we want other people to use or see the app, not just us, we need to host it on the cloud. What does that mean? So when I copy this URL of localhost, let's say I want my friend to test it. This is what it looks like to him, because his local machine doesn't have the files needed to run the RSVP website. So when you host something locally, it means your website is running from your computer. Only you can access it because it's not published anywhere online. It's perfect for testing and development, but once you close your laptop, your server disappears. On the other hand, when you host it on the internet or in the cloud, it means your files are stored on a server that's always on and accessible anywhere in the world. So even if your computer is off, anyone can visit your site using a public link. So again, we're ready to upload everything to the cloud. We will use Amazon S3 for our static website files and Amazon CloudFront to make it load fast anywhere in the world. So this will be the final step, putting our entire full stack application live, where other people can access the same event RSVP site that we've built. First, we will upload our front-end files, all the HTML, CSS, and JavaScript, and our website assets like the banner images to an S3 bucket. Now, S3 stands for Simple Storage Service, so you can think of it like a big online folder that stores any kind of file, documents, images, and in our case, a website. So think of Amazon S3 like it serves similarly to Google Drive, OneDrive, and all other media storage out there. So let's create a bucket. So again, make sure the region is on Singapore or the region where you will host your website. So if we go down here, make sure this is ticked, make sure it's checked, because CloudFront will handle the public access while our S3 will stay private and secure. So with S3 and CloudFront combination, our S3 bucket will stay private and our CloudFront will serve the files publicly. So we have better security, speed, and control. So let's create the bucket. Now, let's upload everything. And let's upload it. Now, let's create a folder for our banners. And upload your banner files or your banner images here. Now, let's go to CloudFront. So CloudFront is a global content delivery network. So it means it will copy your website to data centers worldwide, and it will serve the files from nearest location to each visitor or each user. So it will have faster loading for user everywhere, and it has a built-in DDoS protection. So let's create a distribution. Just name it CloudFront. First, we'll have a single website. So specify origin, of course, Amazon S3, because again, our files is stored in Amazon S3. So let's just choose our bucket right here. So allow private S3 bucket access to CloudFront, yes. And let's just use the recommended settings. So let's not enable WAF for now. This is a small project, but definitely in your big projects, I recommend that you use WAF. So while waiting for it to deploy, let me explain what CloudFront is. So again, it's a content delivery network. If someone far from Singapore visits our website, it's gonna load slowly. And CloudFront solves that problem. It will take your website's content, the HTML, CSS, images, everything, and copies it to servers all around the world. So now when someone visits your website, they don't have to go all the way to your original S3 bucket. Instead, they automatically connect to the nearest CloudFront edge location, which delivers your website much faster. So think of CloudFront as a network of mini S3 buckets spread across the globe, but instead of storing everything, it caches or it saves temporary copies of your files. That's why when someone in Manila or Singapore or even from the US visits your site, they will all get the same content and it will load instantly because it's being served from a nearby edge server. Now, another reason again why CloudFront is important is security. Normally, if your S3 bucket is public, anyone could try to access it directly, which isn't ideal if you want a professional setup. But with CloudFront, again, your bucket can stay private and only CloudFront is allowed to fetch files from it. So your website stays public, but your bucket doesn't. So it's like putting a secure window between the world and your data. So in short, CloudFront will make your website faster, safer, and global. It's like the delivery guy that brings your website closer to your users. So how does that work? We have what we call bucket policy. It says here that our CloudFront distribution can get objects from our S3. Now, the next thing we should do is we should set a default root object. Right now, if we do this, it doesn't work. If we add index.html, it works. But we don't want this in our website. It doesn't look good. So we're gonna go to our distribution. We're gonna click settings and click here the index.html. Without the default root object, the CloudFront won't know what file it's gonna serve first. But now, when we visit our site, the CloudFront is like, okay, I understand that I should serve index.html first. So now, our website is properly live or is now in the cloud. Now, what's next is we have to update the banner. So earlier, we uploaded our banners. We're going to update our banner URL column values. What we're gonna do is, again, we're gonna copy the distribution domain name. We're gonna update our banner URL right here. So we're gonna update our events table. We're gonna set the banner URL. We're gonna paste our URL right here. We're gonna put banner since it's the folder name, and then we're gonna add the file name. So for example, for my Builder Cards Tournament JPG, where event ID is equals to where event ID is Builder Card Tournament. So when we run this, now when we select our event, you will see the banner right here. And when we refresh the page, sorry, I forgot the HTTPS there. So let's just set it again. Now let's refresh it. It's gonna show the banner. Now let's do the same for the other events. We refresh it. Now our banners have completely changed. Now your RSVP website is on the cloud and it can be accessed by anyone. So now we can RSVP to our event. Let's have another example right here. It reflects immediately. So right now, you can see that we were able to list all our events. We were able to get the details of an event. We were able to see the live counts, how many said yes, how many said no. We were able to see the list of the attendees, and we were able to RSVP. So you can say that it was able to call all our functions properly. And now you can distribute this link to your friends or make your own RSVP event site with your interest clubs or your organizations. Now I'm gonna show you something. So our website URL is the CloudFront distribution. But when we check the network tab, it will show the Lambda URL. So why is that? So our project is a full stack web app, which means it has a front end hosted in S3 and CloudFront and a backend, which is our API that we built using Lambda and API Gateway. So there are two different parts hosted in two different AWS services, but they talk to each other. When you open this link, you're accessing your CloudFront distribution, which is serving the static files from the S3 bucket. So the URL wholly hosts the front end. It doesn't actually run any backend code itself. It's just like opening a folder of website files that are displayed in your browser. So when your browser loads that page, all your front-end files are downloaded from CloudFront. Now in the network tab right here, this is the one that will trigger your Lambda function behind the scenes. So even though your website's domain is from CloudFront, the JavaScript running on that page is sending requests to another AWS services, which is API Gateway to Lambda. And again, when we refresh this and when we click it, it sends the base URL link. The base URL. Think of it as CloudFront, where your website lives, and the Lambda plus Gateway is where your logic lives. They work together, but they're two totally separate layers in AWS. So for the cost of our front-end layer, Amazon S3 charges you based on two things: how much data you store and how much traffic your website gets. So right now our files are really small, usually just a few megabytes, right? So the free tier, it will give you 5 GB of storage and 20,000 GET requests per month. So unless your site goes viral, that's completely covered. So even after the free tier, our S3 will cost around $0.023 gigabyte, around that per month, which is like a few pesos. Now for CloudFront, it's almost mostly free for small projects like this one. So the free tier will give you 1 terabyte of data transfer per month for our first year. And that's way more you'll ever need actually for a demo or portfolio site. And after that, data transfer is about $0.085 per gigabyte. But again, if only you and a few people are testing this site, you will never hit that. So as long as you're just building, testing and showing this to friends or for a presentation, so you can expect that your front-end costs will stay at zero. And if you're done working on it or don't need it public for a while, you can disable the CloudFront distribution to make sure you're not billed for storage or transfer at all. And that's it. You have just built and deployed your first full-stack AWS project. You now have a working web application that's live on the internet, hosted entirely on AWS, meaning anyone, anywhere in the world can visit your website and interact with your backend in real time. This is the same architecture that many real companies use for scalable apps. And the best part is you did it all step by step with just the free tier or for a low cost. So let's do a quick recap of the architecture we built so you can clearly understand how all the AWS services fit together. Now let's put all those concepts together using this diagram. On the left, we have the client. That's the user visiting the website. The web server here represents our frontend, which will be hosted in Amazon S3 and delivered globally using CloudFront. When the user clicks something like opening an event or submitting an RSVP, it sends a request through API Gateway, which acts like the traffic controller. The request triggers our application server, or in our case, Serverless, where our Node.js code runs. Then Lambda talks to our databases, RDS for again structured event data, and DynamoDB for live RSVP counts. Finally, the data flows back through the same path to the user, creating that smooth front-end to back-end experience. So if you made it this far, give yourself a pat on the back or a round of applause or even a small treat because you now officially have your first AWS full stack app live on the cloud. So I will wrap up this tutorial with a cleanup and cost control section. I'll give you two tracks. First is you can pause or hibernate the AWS services if you're not gonna use it for a while. This is to stop charges but keep everything ready to resume. But this might incur small charges in your account. Next method is we're gonna archive and tear it down and go back to zero ongoing cost. Meaning we're gonna back up first and we're gonna delete. Okay, let's clean this up. Let's go to our AWS console. So if you want to pause this project or hibernate it for a while and you want to resume it later without any more hassle, but you're gonna use it or you want to show it a few days after to your friends or to other people, we're gonna pause the services first. So click our DB instance, and in actions, you can stop it temporarily, not delete. So you can stop it temporarily. So you can acknowledge it and you can stop it. So with this method, data is preserved on storage and the compute billing pauses, but you will not be able to access the database because it's stopped temporarily. Next is for CloudFront. For CloudFront, just tick the checkbox and you can disable it. So when we disable it, it will stop the data transfer or requests. But you can just quickly re-enable it if you need it again. So when we refresh the site, we cannot access it anymore. For API Gateway, so you can keep it because the idle cost is tiny. But if you want no public hits at all, you can remove your custom domain if you have set any, or temporarily remove the roots. For Lambda, no action needed. As long as nothing's triggering the Lambda function, it will not cost anything. Same with DynamoDB, no action needed. Because on-demand tables at idle will cost near zero or it will not do anything. And for the S3 bucket, just keep it or make it private and there you have it. So this pause state typically keeps your monthly costs near zero while staying one click away from a live demo. But if you want a complete zero cost after this, and you're just done with the project, and if you won't use it for a while, we can archive then delete. So follow me because this is supposed to be in order. First, let's start with DynamoDB. So actions, and then we can export it to S3. So we can just use the same bucket. Export it. So just turn this on. And let's export it. So it's exporting. For the Lambda, you can just use Git or GitHub or push it to a repository so your code is safe. Or for front end, since we already started in the locally, just keep it from there, or again, you can just push it to your repository. Our DynamoDB backup is here, and you can just download it. For the RDS, what you can do is we can take a snapshot, but now we can't, it's grayed out because it's currently stopping. But yeah, you can just take a snapshot, and it will have like a backup configuration. But honestly, for this kind of project, since it's really simple and you already have a tutorial you can follow, I would recommend just deleting it, because I think the snapshot has a little bit of cost as well. Now that we're done backing up, we can delete now our live resources, starting with the CloudFront. So it's disabled. Now let's just delete the distribution. The deletion of a CloudFront requires disable status first, so make sure it's disabled first, then we delete it. Next is the API Gateway. So let's delete all the routes. Clean it up. Let's delete it. Now let's go to our Lambda. So make sure again that you already have a copy of your code either in local or in your repository. So let's delete the function. IAM Roles. Let's go to our event RSVP handler roles. Let's delete them. Okay. Next is the RDS. You can create a final snapshot, yeah. So just delete me. So I don't need it for now because since it's a simple project. For S3, since your DynamoDB backup is here, you can keep it since it won't cost that much. It costs like a few cents per month. But if you want full zero cost, you can just download everything first, and then we can empty the bucket. So again, download everything first and just delete it. So now that it's empty, we can delete the bucket. So delete the bucket. Now, let's go to our networking stuff. Let's go to our security group. So if you created your own security group for this project, delete it if it's not attached to anything anymore. Same with custom DB subnet groups. So if you created a new one, delete if unused. So when I try deleting the default security groups, I can't delete it because default security groups cannot be deleted. And if the deletion of the Lambda wasn't able to delete your log groups properly, you can do so manually. So let's go to CloudWatch also. You can just delete this. Okay. And then our DynamoDB. Just delete this. So for the budgets, just make sure that the budget that we set stays active so you can be notified. Okay. Again, what you can do is just, for example, when you're just done for the day, you can stop RDS and disable CloudFront to avoid charges. But if you're pausing longer, I recommend that you export DynamoDB to S3, you snapshot your RDS, then delete the live resources. Because you can restore everything later in a few clicks with the snapshot and the DynamoDB and S3. But again, personally, I recommend just to delete everything because this is gonna be just a small project. So again, for VPC and security groups, actually there's no direct cost for them. So AWS doesn't charge you for just having like a VPC or a subnet or security groups. You only pay for the resources running inside the VPC. Like again, the RDS and the EC2 and the NAT gateway and etc. So after this project, you can safely keep your VPC set up for future projects. And that's it. You just fully built your very own AWS full stack project from scratch. I'm honestly so proud of you because you didn't just follow a tutorial, you actually learned how real cloud systems work. So whether you built this to learn or to add to your portfolio or just to challenge yourself, I hope you're taking a moment right now to appreciate how far you've come. So you've just connected so many pieces. Databases, API, backend logic, and a front end that actually live on the internet. That's such a huge achievement. I'm so proud of you, and I'm so happy if you were able to reach here until the end. If you have completed this tutorial or even made your own version of this project, like a booking site, a club dashboard, or even your personal portfolio, please show me because I really want to see. So tag me online or drop a comment of how it went for you because I'd love to see what you build with it. So keep creating, keep experimenting, and remember, you're already building the kind of things you once thought were too hard. So again, thank you guys so much for watching this video. This is my first hands-on tutorial here on my YouTube channel, and if you want more, just let me know. And yeah, I'll see you guys in the next video. Bye everyone! Congratulations!